Yes. So I mentioned, yes, it's a bit vague. I know. I mean, that's kind of purposeful. But so mid-shelf is what we're aiming for. Maybe the near shore 50 meters. Sort of out to the 50-meter isobath, which is quite extensive in this study region. But we are open to suggestions. If there's strong justification, then we would expand this. The shaded region of the coastal domain. I'll just take some. The shaded region of the coastal domain goes out to the shelf edge, and for example, in the Beaufort, that's roughly 500-meter isobath. So, although the process studies would focus on the what we would call the coastal zone, perhaps, doesn't mean that we would exclude beyond that. And to fully understand the coastal domain, we would need models that model the open waters in the Beaufort Basin, as well as the Canadian, the other portions of the Chukchi Sea and the Bering Sea. I mean, it's just, you can't just put hard boundaries on that. And the remote sensing as well.
So for those of you who are not Arctic folks, that's one of the most complicated pieces because the ice ain't straightforward to model. Yeah, and it's not just, it is there and it's not. Now there's all kinds that happen within the ice, through the ice, and they all vary depending on when in the ice making or ice losing process. And those who are involved in Arctic region models are spending an enormous amount of energy on that right now. The shallow end is the estuary because this is the land ocean. So hence why all of that emphasis on helos and all kinds of things that allow you to sample that a large vessel, which is the more traditional approach from an oceanographic perspective, won't cut it.
Lee.
I just add to that, can you guys, I'm sure.
Lee Cooper, University of Maryland. I just wanted to add to that a little bit. Some of this is related to the study area. So if you're in the Chukchi Sea, you could make the case the coastal zone extends hundreds of nautical miles away from shore. And if we focus more on the Beaufort Sea, it's a very narrow shelf, and it's much more tractable to. So it's a complex system, and several different ecosystems that are involved that operate in different ways. It adds to the complexity of what's being approached here.
Thank you, Scott. Dennis Hansel, University of Miami. So I see the word change a lot, and I'm trying to get a sense for how much of this is time series kind of analysis, which is what you require for understanding or observing change and then try to understand it, versus more of a process approach to it. And how much of a synthesis looking back have you got planned? Because change, if you're not looking back, because it's going to take a long time to go forward, right, over our lifetimes to see this, to be able to resolve change that's relevant to these questions. You have to do a lot of backward looking as well. So how does that work?
Well, so one of the impetuses for this project, kind of how it got off the ground in the first place, is a brainstorm with Antonio and some others here looking at the possibility of doing hindcasting. And so we've got satellite remote sensing data that goes back to 1997. And so part of the idea is that if we can tie the stuff on the ground to what we see with the satellites here, if we can get those models done well enough that we can go hindcasting back to about 1997, and so we can get an element of that past part of it. You asked about whether this is a time series or whether it's a spatial gradient here, and we're very much interested in the spatial gradient, and what we spent a long time talking about the concept of transformation zones and hotspots. as you go from the riverine out into the coastal zone? Where is it that all of this material that's coming in from these rivers is being changed? How is it changing? How is it impacting things? And so the idea really is to think about it as, following, tracking the carbon, tracking the nutrients, tracking the heat from the rivers all the way out, and trying to understand where is it behaving conservatively, and where is it actually being transformed into something else, and what is the impact on the overall biogeochemistry of the coastal zone. So it's both time series and spatial. We're really interested in that gradient from the land out to the ocean interface here, and we want to figure out what those hot spots are, where those transformation zones are. And so that didn't really come out. I think we had that kind of language in some of the earlier questions, but I think that kind of got weeded out as we were trying to battle with terminology that some communities use, but others have a different idea about what it was. And so we sanitized it a little bit, but that is very much in the idea that we want to know what those transformation zones are. Does that cover your questions, or do you have more?
Yeah.
And also, as we see on the timeline, we're going to have at the beginning of the program 1 or 2 years where we're going to try to synthesize existing data sets, existing studies, and perform some of these analyses that you mentioned, that we want to go back and see what has been done so far, and try to capture temporal chains with time series that have been collected over the past years. And also, this is going to be part of the synthesis towards the end.
In fact, the panel actually recommended that we had initially planned for a 1-year pre-work period phase. They actually suggested 2 years, and to expand what we suggested could be accomplished during that pre-work. Obviously, there are certain synthesis activities that have already taken place. I referred to the SOAR activity that was completed in 2015. So these ongoing syntheses that are done by other groups, necessarily with the same objectives that Arctic Colors has, but those publications are extremely valuable, and those data sets are extremely valuable for Arctic Colors.
Yeah, so I just want to say that also, so those are really good points. But one of our working hypotheses is that it's not too late to establish a baseline right now. And so I think this is one of our main emphases. And it's a difficult problem, because we don't want to, we can't establish a rate of change in the 4 years that we have field work. And it's even worse than that. It's kind of a second derivative problem where we're trying to characterize the rate of change of the rate of change, how the change is changing. So it's not going to happen in 4 years, but we can establish that baseline.
So, given that it's 4 years, I think it's really important that part of this be establishing the capability and extending the observation capability so you're able to interpret those things for the next many, many decades, right? So you don't want to have 4 years and walk away and say, well, this is what we have. You have to establish what's going forward so it's always there, whatever it takes.
You also, all of you have to remember that doing time series in the Arctic logistically is a difficult question. Yeah, it's not as though there is an outlet right there, and you have this small inconvenient thing which is called ice and freezing temperatures. And so it is not a friendly environment to do year-round observations. Having said that, there's lots of development which are happening, which have happened recently, such that we can do those things. There's a question here.
Just before.
Wanted to add something else, that also a big effort in this program is going to be developing and establishing more collaborations in the Arctic, because we would like to be able to extend some of these measurements beyond Arctic colors. So it's not, we see that it's not going to be just this 4 year of measurements. Hopefully some of these measurements are going to continue at some of these sites with the help of our collaborators there. So it's going to be longer time series that are going to result as part of Arctic colors.
And there's a modeling component to it as well, and Margie's not here. She's sort of our modeler expert in our group. But the idea about being able to do predictive models and being able to look out and do sensitivity analysis and trying to understand, what are the most what are the vulnerabilities out into the future in terms of how things are going to change? What changes in the Arctic are going to have the most, or changes in, I don't know, the parameters that we measure? What are the ones that are going to be most sensitive in these models looking out into the future? So there's the modeling aspect of it as well that we're going to try to capture that future aspect of it as well. Just one aside here. Antonio had mentioned in his talk that the idea that there's 750 petagrams of carbon in the atmosphere. It's 850. That's how rapidly things are changing right now. That data is 25 years old, and we're already up to 850. And so that's globally how quickly things are changing, and it's accelerated in the Arctic. And so if the atmospheric carbon can change that much in such a short period of time globally, and things are faster in the Arctic, that just kind of gives you another sense of the urgency of why we need to go after these questions.
Philip Boyd, IMAS Australia. In part, you've answered some of my question, which was really when we heard about the new normal, it started to ring some alarm bells with me, because of course that's an incredible challenge from some of the work, for example, in the Southern Ocean. We see the confounding influences of things like PDO on the whole cryosphere, and just working out exactly where you are in these various cycles in terms of climate variability. Never mind dissecting out where climate change is coming in there. And so, do you think you've got the right data sets in the can to be able to corroborate this across multiple sort of properties to actually then work out, or at least constrain, the new norm?
We hope so. And so, no, what happens ultimately, some of that is not within our control, right? The funding is going to determine some of that, the availability of sampling resources, a whole bunch of other things. And as Antonio said, we, on purpose, the document is broader than just what NASA would intrinsically cover. And hence, the NASA panel has asked us to focus. That does not mean in any way that the parts that may not be remain within this focusing are not important. They just may not be as relevant to NASA. And so it is up to this community then to push for those other pieces, hence why the collaboration with other agencies and foundations or whatever it is from here and yonder. Okay?
But still, I mean, there's a lot of value to be gained from the near historical record, where you can look through and see what sort of modes of variability are coming through, and you can start to then see where we're at, where we think we're going, and build a framework around that there.
Absolutely. Some of that is already happening, just not in this near coastal zone, where the data are significantly less, and even the remote sensing observations are. Yes.
Thank you. Robin Conmey, EPA. I have to commend you all. I've read through the scoping document, and I thought it was a really good first draft at looking at a very important part of our ocean that we have such few measurements for. So I think this would be a really great field campaign, especially with refinement. One thing that I did see, and I've talked to some of you about this, that I felt was a bit absent from it, was that we talk a lot about carbon sources, and trying to get at this, as Antonio put it, not continuum, but sort of contiguous, different pieces. But absent from the document was the thought about natural oil seeps, which in the coastal Arctic is, there's roughly, and of course these measurements are very sparse, but it was estimated about 1,000 tons per year of carbon enters the coastal part of the Arctic. And so I think about the measurements that you all are planning to make, and even if you just don't, think about the fact that there is this other part of carbon source that we need to think about to that region, but just the measurements that you plan to make, a lot of them will have interference problems. Absorption measurements, fluorescence measurements, all of these things with in situ sensors. will have interference problems if you're over a seep. So I'm wondering if you have given some thought about how you all might tackle that or consider it as something in that particular region of the ocean that has to be accounted for.
So I'll try to give you an answer. First of all, it's not the measurements that we are planning to do, it's the measurements that we are all planning to do, right? We're not going to do this. We'll try to write our own proposals, but it's everyone. That's the whole point of this conversation. There are all kinds of things that didn't make it into the proposal, and we tried. Yes, we do. The document uses the word carbon, but it uses organic matter a lot more. Yes? It's not supposed to be too specific about carbon. Somebody told me, how about you don't have sulfur and you don't have this and that and whatever. Still, it is the process, hence the emphasis on the processes. What can I say? Right? The currency is carbon after all, and hence it is across everything. But whether it is the source is natural oil or the source is terrestrial input, the main point it is that it is in that region. So I would encourage you to submit something, as well as encourage your program managers to support something.
I would add that the individuals that would propose and will participate will have to take into account all those issues that you brought up, obviously. I mean, that's very important. And we can point that out. I know we tried to take the comments that you provided into account, but that's something that we probably need to expand on just a little bit further, at least, so people are aware of it.
I also would like to compliment you for writing this document, and as you say, Patty, it's a great framework to integrate many different types of measurements at different time scales and spatial scales. And I just want to point I saw, Antonio, on your map, you had Barrow pointed out as a particular research station. There's, of course, as you know, a long record of sea ice and under ice measurements there, and Hayo-Aiken's ice camp, for example. And so it'll be great to include those records, long-term records, in terms of the hindcasting of the development of the sea ice blooms. And I've worked in that area, and we've seen some very unusual early precipitation events and effects on the under ice bloom development. And so there's there's other stations where there's a long record of sea ice community research.
I have a question for the audience. What aspects of what's here excites you? And if it doesn't, what would excite you? That's really what we would like to
But it has to
hear
do with
about.
the Arctic. You have to keep it focused on that.
Yes, please focus on the Arctic, preferably this.
And it has to do with the near-shore Arctic, not even coastal Arctic, the near-shore Arctic. So don't talk about, the deep Arctic.
And this is part of revising the science goals for Arctic colors. So as we're refining the science for Arctic colors.
You don't need to justify or explain. Just shout out what excites you. Is it sea ice? Is it under ice blooms? What aspect?
So I'll jump in, even though I'm the one carrying the mic and probably should keep my mouth shut. But I'll jump in and say one of the things that I'm really excited about is the idea that we're going to be able to constrain and better understand river discharge. From a carbon perspective, the transformations that happen right there just outside the estuary environment and that near shore is not something that's really easy to get funded, and it's not something that's really well understood. Some of the work that has been coming out of the Arctic and the subarctic lately also suggests that it's really important. And new technologies are currently being developed that are going to enable us to get there a lot easier, not just with ships and small boats, but also with gliders, floats, and drones. So I think this is a great moment to actually try and constrain that question, and I'm really excited to see that Colors is emphasizing sort of that often neglected strip of near-shore measurements. So I would say the river discharge is one of the things that I'm most excited about.
Well, that really gets at the transformation zones that I talked about earlier. I mean, I'm a river guy, and so that's what I'm most excited about too. And just the idea about rivers passing through a delta. What happens as it goes through the delta? What kind of the exchanges you can have with the delta waters? All the transformations that happen along that part. That's a really poorly understood piece. Just what happens as it goes through the delta.
Absolutely.
Yeah, my vote would be the permafrost question. Mobilization of that carbon is much more of a potentially existential kind of situation for us than just transformations. I mean, transformation is important. Want to understand it, but if you say what's really important here, it's mobilizing 1,700 petagrams of carbon, right? So that's fundamentally where I'd put my bet.
Are there any plans to assess that outside of U.S. territorial waters? You guys have any partners in the East Siberian at all?
So our thinking on that is that, I mean, obviously, ideally, there would be a pan-Arctic activity, but at the stage that we've been at, it's really hard to start engaging other communities on those issues, whether it's the with the Europeans and so forth. But
It may happen.
it
But-
may, I mean,
It may happen out of organic growth, but right now, no. We were told to focus, remember?
It's
But
like-
hopefully, as the program moves forward,
Yeah.
we would be able to establish exactly this kind of collaborations you mentioned. Yes.
It's like Field of Dreams. If they fund it, they will come.
Yes.
One of the things we did for above with that sort of pan-Arctic concept is that we would consider proposals responsive to above that were circumarctic from remote sensing, satellite remote sensing. So you could consider something pan-Arctic from satellite remote sensing that didn't require airborne or ground activities outside of your spatial domain.
Yes.
Yeah. For example, characterizing erosional rates may be possible.
Any last comments or questions? Because we're running up against the switchover. Okay, I think we should thank the panel and the speakers.